going to graph a cycle of a cosecant wave. This cosecant wave has a lot of transformations involved. It asks to state the period, but we will also be stating the amplitude, the phase shift, the vertical shift, the period, even the frequency. A lot of other questions could be asked of this. But the first thing, right off the bat, is I don't want to deal with cosecant, so I'm going to think sine. So I want to take a look at 3 sine pi fourths x minus 1. I will get all my information from the sine wave that will allow me to graph the cosecant wave. So the amplitude is the absolute value of the coefficient of the function, in this case 3. The period is the normal period for a sine wave, which is 2 pi, divided by omega, in this case pi fourths, and if we simplify that we get 8. The phase shift is what makes the inside of the sine wave equal to 0. You can set the inside of the sine wave equal to 0, but in this convenient factored form we can see that x equals 1 is the phase shift. And then the vertical shift would normally be out here, the constant term, but in this case is 0. That's the only one that's not just visible that you can just look at and get or work out quickly from what you can see. So I put it in a little different color. Okay. Now, in comparing the phase shift and the period, a sine wave undergoes a normal period between 0 and 2 pi, up to amplitude, down to amplitude. It really has 4 sections to it. As it's going up, it's back to 0, and these aren't vertical asymptotes, these are just sections of it. And they correspond with the unit circle as the cosine wave goes from, this is the 0, 1, to 0, to -1, to 0, back to 1. It corresponds to the 4 quadrants. So what I like to do is take the period and divide it by 4. And now, comparing the phase shift and the fourth of the period, the smaller is 1. This is what I'm going to do to set up my tick marks. I'm going to do maybe here. So that's 1, another tick mark, 1 over, 1 over, 1 over, etc. And that's not 6, that's 5, 6, 7, 8. I don't know exactly how many I need to do. You could even go backwards. So again, the way I set up the tick marks, take a look at the period, 8, divide that by 4, in this case is 2, and look at the phase shift and determine the smaller of those 2. Now if you happen to have fractions, then I usually go for the common denominator, smaller of those 2. In this case 1, so I'm going to set it up my tick mark as 1. Now the amplitude is 3. Combining the amplitude and the vertical shift, I can get an idea of how I want to set up the y-axis. In this case, I'll just put this up at 3. This will be down at -3. Okay, we're basically set to discuss where the sine wave would normally go through. So the sine wave normally starts at the origin and repeats itself after a period. Our sine wave is starting right 1 from the phase shift, up 0 from the vertical shift. So this is where our sine wave is starting. The period is 8. So 8 to the right of this, it would be back to that same point. Halfway between the period, it's also at the baseline, so that would be at 5. Then halfway between those points, it's at amplitude or negative amplitude. This depends on the coefficient of the sine wave. This one's positive 3, so this does the normal sign of going up first. So from here, up, and then through that point, and then down and through that point. That's the typical sine pattern. This is enough for us to set up cosecant. Don't graph the sine wave though, because if you graph the sine wave that we've been thinking about and then graph the cosecant wave, a lot of instructors will not give you full credit because only the solid parts of a graph are actually what you're graphing. The dashed lines and other things are not part of the graph. They just help you out. So you could dash the sine wave through here, but I'm not even going to do that. All right, discussion time. Cosecant is 1 over sine. Wherever sine would be 0 at its baseline, in this case actually on the x-axis, that 0, the cosecant would be 1 divided by 0, which is undefined. So everywhere that sine was at its baseline, cosecant is going to have a vertical asymptote. Next, where sine is at value of 3 at amplitude, cosecant will be, well, it's not 1/3. I'd have to analyze a little bit more, but where sine is at amplitude, cosecant is at that same spot. So these are actually points on the cosecant where sine is at amplitude. And then the cosecant goes up or down towards infinities from those points. And it's stuck between the asymptotes. And that would be the graph of one cycle of this specific cosecant wave. And that's all based on the underlying sine wave and where it's at amplitude and where it's at baseline. So to follow up on some questions, obviously amplitude, period questions, phase shift, vertical shift, but they could also ask about asymptotes. In this case we have 1 and 5 and 9 and etc. You can also just pick an asymptote and then add the period. The period is 4. Not the period. The distance between asymptotes is 4. So you got 1 plus 4k. So these are x equals, because they're vertical lines, k and integer. That's a nice way to list all of the asymptotes. Pick the first asymptote, any one you want. You could have done 5 or 9. And then how far is it to the next one? Then generalize that with a k. And then describe k as an integer. And last, the domain. And that's just the set of all x's such that x is not one of the asymptotes. There we go. Okay, hope this helps.